drawing and load applications in a concrete beam. In this video, you will learn to draw a concrete beam in the SAP 2000 software and assign loads on it. This is the problem statement for this exercise. You have to draw a concrete beam of span 8 meters, supported at its two ends, and subjected to a uniform dead load of 5 kN per meter. The beam is made of M30 grade concrete, with reinforcement bars of HYSD 415 grade, as longitudinal, and mild grade 250 as confinement bars, and the beam has a section of 300 mm by 300 mm. Open the SAP 2000 software. Go to File, and click on New Model. Make sure that kilonewton, meter, Celsius option is set as the default units. Then click on Beam option from the templates below. The beam is evidently of one span. Therefore type the value 1 in the space for number of spans. Set the span length to 8 meters. The supports in the beam are restrained, one being pinned, and the other is a roller joint. So make sure restraints is marked. In the section Properties, the beam is set to be of default property. This means if you draw with the default property, the software will assign the predefined property on it to the beam. Click on the plus sign next to the Beam Properties option. You can see that there are no properties defined. So the beam will be drawn but with default properties. You will draw the beam first, and later define the required property, and assign it to the beam. Click on OK. Click on OK again. The beam of one span, with 8 meters length, and having restraints at its ends, have been drawn. Now, you have to set the given properties to the beam. For this, you have to define these properties first. First, you will be defining the materials that the beam is made of, and then define the beam section with the defined materials. Go to the Define menu, and click on Materials. You can see that, in the materials list, 2 materials are present by default. These are 2 common materials, as per international standards. The materials in the problem statement are not there by default. So, click on Add New Material. First, let us define the M30 concrete material. Select Region as India from the drop-down list. Similarly, select the material type which is concrete. The standard refers to the specifications, which will be followed. Make sure it is set to Indian. Then the drop-down list for grade will list of all the concrete grades present in India, as per Indian standards. Select the M30 concrete from the grade. Click on OK. You will see that M30 now appears on the materials list. M30 is now a defined property, and can be assigned to any section. Similarly, you will define the reinforcement bars, that is HYSD grade 415, and mild grade 250. Again click on Add New Material. Select Region as India. This time change the material type to rebar. Standard will again be Indian. Now, the list of grade contains rebar materials of India, as per Indian standards. Select the HYSD 415 option, and click on OK. Repeat the same process for the mild grade 250 material. Just change the grade to MLD grade 250. You can see that all the 3 materials that the beam is made of is now in the materials list. The materials have thus been now defined. Click on OK. Now that the software recognizes the materials, you will be defining the section of the beam with these materials. In the Define menu, go to Define Sections, and select Frame Sections. As the beam is a frame, therefore you are selecting frame sections. There is already one predefined section in the properties list. Ignore that property. You will define a new property completely. Click on Add New Property. The frame section property type is set to steel. Thus, all available common steel sections used in the construction industry, like the I section, channel, T, angle sections, etc., are listed, and you can select the suitable option from here. But you are defining a concrete section, so select the concrete option from the frame section property type drop-down list. The available concrete sections that are rectangular, circular, pipe, tube, trapezoidal, and tube precast types are listed here. The beam is of rectangular section, so select the rectangular option. Now, in the section name option, type a name which you can identify later, while assigning the property. For instance, you can type B300 by 300, to refer to a beam, having 300 mm by 300 mm dimensions. Set the depth, and width of the beam, which is 300 mm each. 300 mm means 0.3 meters. Since the standard units are in meter, so type the value 0.3, in both depth and width. Now in the option for material, select the previously defined beam material, that is M30. The concrete material has been added, but you are yet to set the reinforcement, in the section. Click on the concrete reinforcement option. The reinforcement data dialog box will open. Set the longitudinal bars material, to HYSD 415, and the confinement bars material, to mild 250. As you can notice, the drop-down list shows only the defined rebar materials. If you had not defined them previously, you would not be able to select them here. Change the design type to beam. In the space for concrete cover, you will use the standard clear cover, as per IS code, which is 25 mm, for a beam. So type the cover values, in both top and bottom as 0.025, which is the cover value in meters. Ignore the reinforcement overrides for ductile beams option. This option is relevant if you are considering ductile detailing. Click on OK. Then click on OK again. Now you can see the defined frame property, in the properties list. The software now understands what B300 by 300 is, and it can thus be assigned to a frame. Click on OK. Now if you right-click on the beam, you can see that the section property of the beam is the default predefined property in the software. You will now change its property to the defined section. Click on OK. Now left-click on the beam to select it. Go to the Assign menu, then go to the Frame option, and then click on Frame Sections. Now, the list of all defined frame sections appears. Select the property you had defined. Click on Apply, and then click on OK. The beam's property has now been changed. You need to apply the uniform load, of 5 kN per meter, onto the beam now. Select the beam again. Go to Assign, and then Frame Loads. Since the load is acting on the beam, which is a frame, so Frame Loads is being selected. Then select Distributed, as it is a uniform load. In the options, select Replace Existing Loads. The Add to Existing Loads will add similar load pattern to the selected object, if there is some load already. The Replace Existing Loads will replace the similar load, if present in the selected object, with the newly given value. The Delete Existing Loads will delete loads of the given load pattern, on the selected object. Make sure to click the Reset Form option, as there might be some previously entered values, which will just add up to your loads. Select Load Pattern as Dead. Coordinate System as Global. Load Direction as Gravity, and Load Type as Force. The Trapezoidal Load option is for application of uniformly varying loads. The given load is a uniform load, so enter the value of 5 in the space for uniform load. Click on Apply, and then click on OK. Now, you can see the loads on the beam, in one of the tabs. The loads are not being shown in the other tab. This doesn't mean that the loads have not been applied there. Any property you give to the model will be simultaneously set to all the View tabs. It's just that you have to change the display settings to view them. Select the tab which is not showing the applied load. In the Display menu, go to Show Object Load Assigns, and click on the Frame option. Select the relevant load pattern name. Here if it is dead load, you do not have to change anything. Click on OK. You can see that the loads are now being shown in both the tabs. In the next video, you will be analyzing and designing this concrete beam in SAP 2000. You can save this file and open it later if you want to do the next exercise at a later time. Thanks for watching.